Today we're going to discuss expert systems, a very important area in artificial intelligence. Uh, Expert systems are trying to replicate or emulate or mimic the behavior of experts in real life. Before we actually look at the working and structure of an expert system, let's see what exactly do we mean by an expert. Typically, an expert in any area is a person who is first of all educated in a particular domain, and then over the years he or she has built a lot of knowledge and experience, and so people have a lot of faith, trust in their abilities and their decision making abilities. So that is important. And how do they do it? Human beings, first of all, they learn things, maybe by memory, going to school, getting knowledge information there. That's the base level. And then based on that, they start working in a particular domain. It could be medical diagnosis, it could be chemical analysis, it could be mathematics, it could be somebody who's a car mechanic, and so forth. So people who get trained in those areas, and then over years they build up knowledge in that area, and that knowledge is actually helping them make better decisions. So experts, and that's what these are the experts we're talking about. And what we're trying to do is emulate, pick up a particular expert, look at the way he works, look at how they reason about information, how they possess specialized knowledge, and then by the end of the day, I would say that they can actually explain their reasoning as well. And some of the most common ones are a heart specialist, a skin specialist, car mechanic, architect, software engineer. Each of these persons, specific persons, have had basic grounding knowledge and then spent time to actually hone in their expertise. And remember a word we used earlier on called heuristics. So what they do is it's not just the bookish knowledge that they have. That's the basic. That's a given. It's basically that knowledge that they've learned at school and so forth, and then they actually use that experience over years and build up a certain set of rules in their mind, which are kind of shortcuts, so to speak, or the word heuristics. And that's the real expertise that they have, and use that heuristic knowledge information to reason. So they've got a knowledge base as well as the reasoning mechanism that they've built over some years. Expert systems in general are limited to certain areas. If I were to compare, remember the earlier discussion on weak and strong AI? Expert systems are in that context limited to small set of applications in a vertical domain. So in that sense, you could call them as weak AI areas. So they're limited to solvable problems. They reason symbolically, and they reason heuristically, rules of thumb that they have got. And of course, typically, humans also have to work with inexact reasoning, a time limitation. They have to come up with a diagnosis there and then in real life situations. How do they do it? So what we do is we go to a human or a group of humans, get the knowledge base that they have, build a structure which can replicate that behavior, and build what we call as an expert system. If we were to compare experts versus expert systems, so let's say a human expert, availability is limited. An expert may be in one area, let's say in Lahore, and you got a problem in Karachi, limited availability. Whereas if you have an expert system that can replicate the working of that expert, that is available everywhere. Geographic location for safety considerations, durability. Human beings can have variations in their working. Sometimes they are feeling good, sometimes they're not feeling good. Their performance could vary, but not that of an expert system. That's a machine. Speed and cost. These are the benefits that you get from using expert systems. They will always give you, a result within a specified time, as opposed to experts, human experts. If they are fresh, they can, come up with a solution there and then. If they're not, they'll take their time. Explanation, and very important part. Sometimes you like to know why a doctor made a certain prescription. Why did he say, he's suffering from this problem or that problem? Sometimes human beings try to explain. Now that reasoning, it's up to that human, that particular expert, whether it's, as I said, somebody who's developing a software, someone who's doing chemical analysis, or someone who's looking at maps from which they gather geological information and decide whether there's oil in there or not. If you ask them, how did you suggest, or how did you think that there's oil here or not there, they may or may not be able to explain that. On the other hand, if you have expert systems that have built, according to the way that we want them to do, then you will have an explanation facility as well. So let's look at the structure. We've got a knowledge base. We've got a working memory, which is something that I'm doing now. What you're doing now is your working memory, the current working memory. And of course, something that reasons. In human beings, we have working memory, a long-term memory where the knowledge base is there, and inference engine is something which replicates the reasoning of the human being. Let's look at an example. In the figure that come before you, we have shown setup of the expert system, how it works. On the left-hand side, we have the knowledge base with the 3 rules in there called rule 1, rule 2, and 3. And on the right-hand side, we have depicted the working memory. Okay, we are well aware of what we mean by a working memory. It has got current facts in it. New facts will be inserted. Sometimes facts will also be removed as well. So what we have, as I said, 2 facts, fact number 1 and 2 in the working memory. Now in the background, the inference engine, the reasoning mechanism system is working, and what it does is it will match constantly. It keeps matching the working memory facts with the rules that are there. And as soon as 1 or 2 or whatever number of facts, they match the left hand side of any of these rules, they will become active. They will be ready to be fired, as we call it. So this is kind of a data driven situation. We are not controlling the sequence of operation of each of these rules. It will depend on the facts that are in the memory and the rules in here. The left hand side of each rule is constantly being matched with the working memory. So let's see here what happens. We have fact number 1, which says father Tariq of Ali, as you can see, and this fact number 1 actually matches the left hand side, the first left hand side of rule number 1. Then also this father fact, okay, which is fact number 1, also matches the left hand side of rule number 2 as well. Okay, so we've already seen 2 matchings here. Okay, 1 and 2, as you can see, for fact 1. Let's move forward. Now we see fact number 2, which is father Tariq of Ahmed, and this fact is matching with the second left hand side of rule number 1, which is father X of Z. All right, so these 2. So what's happening really is fact number 1 and fact number 2 are actually feeding rule number 1, and as you can see, the color of this rule has changed. So this is now activated. We can actually execute this rule. And also fact number 1 is matching with the left hand side of rule number 2, and that also is shown with a green color. So just to indicate that these 2 rules are activated, they can be executed. Let's see what happens. This fact number 2 also matches the left hand side of rule 2. Okay, so 2 facts, fact number 1 and fact number 2, are both matching rule number 2, left hand side. So effectively what will happen is when this rule is executed, it will be executed twice. Let's see. First we execute rule number 1, okay, which says if the left hand side of rule 1 is true, then brother of Y and Z. Okay, so it says brother of Ali and Ahmed. In other words, Ali and Ahmed are brothers. That's a new fact inserted, and as you can see, with a different color. So we started with 2 facts only, and with the execution of first rule, a third fact has been inserted in the memory, which is fact number 3. All right, I hope this explains. Let's move forward. Now, this fact which has been inserted, fact 3, immediately has been matched by the inference engine in the background. As you can see, it has actually changed the color of rule 3. It becomes green, means it is also now ready to be fired. Okay. So at the moment we have rule 2 and rule 3, both can be executed. Let's see what happens. Since rule 2 was already activated before rule 1, so we execute rule number 2, and the right hand side of this rule says that you have to pay tuition of both, because Tariq is the father of Ali and Ahmed both. Okay, so he has to pay tuition for Ali, for instance. Okay, and also, as you can see, fact 4 and 5 have been inserted by rule number 2, which says Tariq has to pay tuition for Ali as well as Ahmed. So just like father's parents, we all do that. So parents are liable to pay fees of their wards. So far, what's happened? Fact 1 and 2 were already in the system. Inference engine matched them to the left hand side of rules, and rule 1 executed, it inserted fact 3, and then rule 2 executed because two facts were matching to this rule, so it was executed twice, and therefore fact 4 and 5 have been inserted. Now we can see that the colors of rule 1 and 2 have changed. They have executed, they are not going to be executed anymore, and the only rule left to be executed is rule number 3, and it's already matching with fact 3, so it is activated. So what will happen? I think you can guess. It will say that X, if brother Y and Z, two people are brothers of each other, then they will actually like each other. That's what the rule says. So I can actually anticipate what's going to happen here, but I'm not controlling. I cannot control. See, so a new fact, fact number 6, has been inserted, okay, because of rule number 3. So to summarize, I hope this clarifies the working of the expert system, the working memory, the way things are executed. And remember, the important thing is the execution of expert systems, the execution of rules, the control programmers. As programmers, we don't control what's going to happen. It is the facts, and they will drive the execution of rules and consequently the consequences of each of these. Okay, so that's different. As programmers, you're quite used to controlling things yourself, but not in this case. This facts versus rules. So this is how the actual working of an expert system takes place, and this is different. The working of these systems is different from the working of conventional software programming that we're used to. It's basically data driven. I hope you understood and enjoyed. Thank you very much. We'll meet again.